Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 9, radicals and conjugates. All right, we're not going to be conjugating verbs here. We're going to be conjugating radicals. Okay, there's a difference. Classwork opening exercise. Which of these statements are true for all A and B positive? Okay, A and B are positive numbers. Which of these three are always true? Well, this is the distributive property. So no matter what number we choose, for example, I will choose 2 or 4, or I don't want to use 2. So my pen is not cooperating. 2, and let's let A equal 5 and B equal 8, just to pick a couple numbers. So then when I substitute those in, it'd be 2 times 5 plus 8 has to equal 2 times 5 plus 2 times 8. Well, 5 plus 8 is 13. 5 times 2 is 10. 2 times 8 is 16. 2 times 13 is 26. And 10 plus 16 is 26. So that was true for that value. And it would be true for all. Now, just picking 2 numbers and substituting in does not prove anything. I would have to find a counter example to disprove it, or another means to prove it more mathematically, but we won't go there. Now let's do number 2. I'll do that in red. So we have A plus B over 2, and A is 5 and B is 8. So it'd be 5 plus 8 divided by 2 has to equal 5 over 2 plus 8 over 2. Well, 5 plus 8 is 13 over 2 equals, and I can add these. And whenever the denominators are the same, you just add the numerator and you get the denominator. So 5 plus 8 is 13, and then 2. So this is also true. 13 halves is 6.5. But when we get to this radical, something's not going to work out for us. 5 plus 8 equals the square root of 5 plus the square root of 8. That would be the square root of 13 equals the square root of 5 plus the square root of 8. So I didn't pick perfect squares here, which is okay. I'll just use my calculator to show this. So if I take the square root of 13 and get a decimal approximation, I'm going to get 3.61. So this is approximately 3.61. And the square root of 5 is 2.24. I'm just rounding to the 100th. Plus, and the square root of 8 is 2.83. Well, when I add those, I get 3.61 equals 4 plus 3 is 7, 8 plus 2 is 10, carry the 1, 2 and 2 is 4, plus that 1 is 5. So 3.61 definitely does not equal 5.07. So we can't split up radicals whenever we're adding the radicand, which is what the number underneath the radical is called. Okay, so there's the opening exercise. Example 1, express 50 minus the square root of 18 plus the square root of 8 in simplest radical form and combine like terms. So if you've never watched my videos before in prior classes, the way I simplify radicals is factor trees. So what I do is I take 50 and I find the smallest prime that will go into 50, the factor that is prime that goes into 50. And I wouldn't pick 5 and 10. I just like to use the smallest first, and I do 2, and I put 25 over here. 2 times 25 is 50. And then I split it up again, and then 25 is 5 times 5. Pairs become numbers outside the radical, because 5 times 5 is 25, and the square root of 25 is 5. So if you have a pair of 5s, whatever your index is, the index is 2 in this case. That's how many numbers you need in your factor tree to make 1 outside. And then my remainder is going to stay under the radical. So I get 5 square root 2 for 50, for radical 50. So if I put that in a radical form, I guess that'd make more sense. Okay, and these would all be in radicals, by the way. And so the square root of 25 is 5, and then you can see it. All right, so then I do it with square root of 18. So if I take the square root of 18, smallest prime that 18 is divisible by is 2. And that will leave me 9 over here. 9 times 2 is 18. So if you think of that as a radical 2 and a radical 9, well, this breaks up to the radical 3 and radical 3. So radical 3 times radical 3 is 3, and I have that square root of 2 remaining. So here's my pair. Okay, and then I'm going to do it one more time with the square root of 8. Well, the square root of 8, a 2 will come out, and a 4 will come out. 2 times 4 is 8. And then the 4 factors down to 2 times 2. And there's my pair. So that will give me 2 square root 2. And now I can add these. Actually, it's minus on this one. So now I'm just going to write the operation. So this is minus, and this is plus. So 5 minus 3 is 2, and 2 plus 2 is 4. So we can add the outside numbers, and then the radical just comes along for a ride. It's just like 5x minus 3x plus 2x, where x is the square root of 2. And this is combining like terms, and 5x minus 3x is 2x, and 2x plus 2x is 4x, and we are just letting x be the square root of 2. Okay? So it works the same with radicals as it does with variables. All right, so there's your example. So now it's your turn. Try exercise 1 through 5. So pause the video, see if you can do this, and then come back. Okay, so here's number 1. I'm going to rewrite these fractions. I'm going to break them up. You can rewrite a fraction like this. If you have a fraction under a radical, if the radicand is a fraction, I can split it up and say the square root of 1 divided by the square root of 4 plus the square root of 9 divided by the square root of 4 minus the square root of 45. That's the first thing I'm going to do. And then I'm going to simplify this. The square root of 1 is 1. The square root of 4 is 2. Plus the square root of 9 is 3. The square root of 4 is 2. And then I need to take this square root of 45 and factor it. 2 won't go. 3 will. 15 times. 15 times 3 is 45. And 15 is 3 times 5. So I have a pair of 3's here. So that's going to come outside, and the 5 stays under the radical. So it's going to be minus 3 square root 5. Okay, 1/2 plus 3/2 is 4/2, which is 2. That becomes 2 minus 3 square root 5. Okay, now just like variables, if I had 2 minus 3x, I can't say that's a negative 1x because these are not like terms. 2 is a constant, and 3x is a monomial with a coefficient and a variable. They're not like terms. It's of degree 1. This is degree 0. You can't combine them. Same goes with radicals. So this is my answer. I cannot simplify that any further. All right, number 2. All right, this is the distributive property. We can distribute. A radical 2 times a radical 2 is radical 2 times 3, or radical 6. So this is the square root of 6. Multiply this times this. Don't forget your minus sign. Square root of 2 times the square root of 2 is 2, or the square root of 4. So the answer is square root of 6 minus 2. Okay, nothing more we can do with that. This is our answer. All right, page 2, exercise 3. Again, we're going to break up this radical and make square root of 3 over the square root of 8. Off to the side here, I'm going to factor 8, which is 2 times 4, and 4 is 2 times 2. My index is 2, so I need 2 of these to go outside. So this is going to equal the square root of 3 on top, And the square root of 8 is going to become 2 square root the remainder, which is 2. Okay, and that remaining 1, that's by itself. All right, so I do not want a radical in the denominator, so I multiply by, let me change the color of this. I want to multiply by a factor or a 1. I'm multiplying by 1, but I want to multiply by the radical because any square root times itself equals the radicand underneath. So this is going to equal the square root of 3 times the square root of 2 is the square root of 6. And root 2 times root 2 is 2, and 2 times 2 is 4. So my answer is 6 square root 4. Okay. Now number 4, it's a cube root. We need to be careful. Cubed roots, what does a cube root mean? It's a number times itself 3 times, not 2 times. So we don't want a perfect square underneath, we want a perfect cube. So when we multiplied this radical 2 times radical 2, we got radical 4, which is 2. That was a perfect square. We want perfect cubes this time, so we need to be careful. So I'm going to split this up just like we did the square root. So it's the cubed root of 5 over the cubed root of 32. All right. Now, what are cubed roots? 1 times 1 times 1. So let's just do this for a minute. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 is 9 times 3 is 27. 4 times 4 is 16. And 16 times 4 is 64. 5 times 5 is 25. And times 5 is 125, and so on and so on. So we're looking for perfect cubes this time. And I see 64 here, and 32 is a factor of 64. So this is one way to do it, and just multiply by square root or cube root of 2 over cube root of 2. We want a perfect cube. So I'm going to multiply the top and bottom by the cube root of 2. Okay, and this is going to give me the cube root of 5 times the cube root of 2, which is the cube root of 5 times 2, or 10. The cube root of 32 times the cube root of 2 is the cube root of 32 times 2, which is 64. All right, so now I have a perfect cube. I can't do anything with the 10. 10 is 5 times 2, and that's it. There's no number that happens 3 times. But the cube root of 64 is 4. So we're done. That is the answer to number 4, cube root of 10 over 4. All right. Now number 5, we have a variable in there and a cubed root. So be careful here. This is going to equal the cubed root of 16 times the cubed root of x to the 5th. Okay, so I split them up off to the side. 16 is not a perfect cube. I do not need to rationalize this, though there's no fraction. But if I look at 16, 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So I have 3 2's here. This will simplify to 2 times the cubed root of, this 2 here is this 2 here is from these 3 2's. The cubed root of 8 is 1 2. I have a remainder here, so I have the cubed root of 2. All right, so cubed root of 16 simplifies to 2 times the cubed root of 2. And then I need to multiply that by the cubed root of x to the 5th. Now keep in mind, x to the 5th equals x times x times x times x times x. Well, I have 3 x's, so I could split this up to the cubed root of x cubed times the cubed root of x squared, which is these 2. Okay, we can do this. And then when we simplify this, the cubed root of x cubed is simply x. Powers and indices, you divide, and 3 divided by 3 is 1. That leaves me x to the 1. So this can go, this right here, let me change colors. This right here can get moved over to outside. So this, we're going to end up with 2. And then the cubed root of x cubed is just simply x. But then we have this cubed root of x squared and a cubed root of 2. Well, I can put those together. So this can become 3, or the cubed root of 2 times x squared, or 2x squared. Okay, combining the cubed root of 2 times the cubed root of x squared. So the answer to this is 2x times the cubed root of 2x squared. So that is the answer to that. That one was a little tricky. We haven't done one of those yet, but this is review from prior math classes. Okay, so there are the 5 exercises. All right, example 2. Multiply and combine like terms. Then explain what you notice about the 2 different results. So let's do the first one here. The square root of 3 plus the square root of 2 times the square root of 3 plus the square root of 2. So this is, think of x plus a times x plus a in our prior lessons. What do? Well, we FOIL. We do distributive property. So the square root of 3 times the square root of 3 is simply 3. The square root of 3 times the square root of 2 is, and it's plus, by the way, plus square root of 3 times the square root of 2, which is the square root of 6, plus, and now I'm going to do the square root of 2 times the square root of 3, which is the square root of 6, plus the square root of 2 times the square root of 2, which is simply 2. Combining like terms, I have a 3 and I have a 2. That's going to give me 5, plus, and I have 2 square root 6s, so you just say 2 square root 6. Now the square root of 6 is 2 times 3, and there's my factor tree, and as you can see, there are no pairs, so I cannot simplify as radical 6. So this is our answer. Okay, there's the answer to the first one. Now let's look at square root of 3 plus the square root of 2 times the square root of 3 minus the square root of 2. Be careful with your signs. When I distribute, I get the square root of 3 times the square root of 3, which is 3. When I multiply a positive times a negative, I get a negative. Root 3 times root 2 is root 6. Okay, and then I'm going to distribute the 2. Positive times a positive is positive. Square root of 2 times the square root of 3 is the square root of 6. Positive times a negative is negative. Root 2 times root 2 is 2. Okay, combine like terms. 3 minus 2 is 1. And minus root 6 plus root 6 cancels. And this simplifies to simply 1. Okay, so as you can see, when we have a radical plus a radical times the same radical plus the radical, we got an irrational complex number. A part that's real and a part that's a part that's an integer and a part that's rational or irrational. So rational plus an irrational. I'll get there some point, okay? But notice what happens here. If we take a radical plus a radical times a radical minus a radical, we got an integer. So if I switch this and I said the square root of a plus the square root of b, oh my. Okay, and I multiply that by the square root of a minus the square root of b. So watch what's going to happen here. The square root of a times the square root of a is a. The square root of a times that is minus the square root of a times b. And then the inside, b times a, is plus the square root of ab. And then a positive times a negative is negative, and the square root of b times the square root of b is simply b. So my radical in the middle cancels out, and I get simply a minus b. where a and b are integers, I'm going to get an integer answer. So this is called a conjugate. Okay, so let's do a couple of examples. If I had 4 plus the square root of 3, the conjugate to that, which would make this true, would be 4 minus the square root of 3. So it's going to have the same number in this position and the same number in or value in this position and be separated by different signs. Okay, so if I had 2 minus the square root of 8, the conjugate to that would be 2 plus the square root of 8. So conjugates are simply just changing the sign in between. Every time we do this, we are going to get an answer that's an integer. And I'll prove that to you on this one right here. 2 times 2, 4, plus 2 root 8, minus 2 root 8. And then a minus times a plus is minus. And the square root of 8 times the square root of 8 is 8. The middle term, that's radical, cancels, and 4 minus 8 is negative 4. There's an integer. Okay? 4 times 4, 16. 4 times negative radical 3, negative 4 radical 3. Radical 3 times positive 4, plus 4 radical 3. Positive times a negative, negative. Root 3 times root 3 is 3. The minus 4 root 3 plus 4 root 3 cancel, and 16 minus 3 is 13. Every single time we multiply by a conjugate, the radical cancels out. Okay, page 3 is now giving us some exercises, kind of what I just did in the last examples here. I gave you some examples, but here's 3 more. So let's do this. So we're just distributing. Square root of 5 times the square root of 5 is 5. The square root of 5 times a negative, careful, positive times a negative is negative. Root 5 times root 3 is the square root of 15. And then the inside, root 3 times the square root of 5 is positive, so that's plus the square root of 15. And then the square root of 3 times the square root of 3 is 3, but it's positive times a negative, which is negative. So root 3 times root 3 is 3. The minus 15 plus 15 cancel. 5 minus 3 is 2. Okay? Again, 7 times 7, 49. Positive times a negative, negative. 7 times the square root of 2, 7 square root 2. Square root of 2, positive times a positive is positive. 7 times the square root of 2, 7 square root 2. Square root of 2 times the positive times a negative, negative. Root 2 times root 2 is 2. Again, middle terms cancel. 49 minus 2 is 47. So what's happening here? We're getting the square root of, or 7 squared, the first term squared, and we're getting minus the last term squared. Okay, so 49 minus 2. 5 minus 3. So square root of 5 times the square root of 5 is 5. I'm going to ignore my middle terms. I'm just going to jump to the last. So if we know that we have FOIL for these, when we do a conjugate, we don't do FOIL, we just do FL because the OI cancels. So first times first, last times last. First times first, 5. Positive times a negative is negative. 2 times 2 is 4. This is going to be 1. Okay? So it's that simple. Conjugate is just first times last. The middle terms cancel. All right, example 3. Write this in simplest radical form. So here's where we're going to apply that conjugating the radical. Why are we doing that? Well, if we have 5 minus 2 square root 3, and we want to rationalize this, we can't just multiply by 2 root 3, 2 root 3. We would still have a radical. And let me show you that. Do not write this. Just watch what would happen. If I just think, well, I'm going to cancel that, or even still, let's just get rid of that radical by multiplying by radical 3 over radical 3. Again, do not do this. I'm showing you a counter example. If I just simply multiplied root 3 over root 3, I would get 3 on top. That's great. but then I'd have 5 times the square root of 3, which is 5 square root 3. And then I'd have minus 2 times root 3 times root 3, which is root 3 times root 3 is 3. 3 times 2 is 6. And I get this. Well, what good did that do us? We got a fraction that's still equivalent to the first one, but it's still an irrational denominator because of the distribution. So we have to use a conjugate to get rid of that radical altogether. So what is the conjugate of 5 minus 2 root 3? 5 plus 2 root 3. Okay, and what you do to the bottom, you have to do to the top because it has to be equal to 1. Anything divided by itself is 1. So all we do is recopy the denominator and change the sign to plus. It's that easy, okay? And you will get the hang of this quickly. 5 times the square root of 3 is 5 square root 3. Plus root 3 times root 3 is 3 times 2 is 6. Divided by, now remember, it's a conjugate, so FOIL, you don't have to do the OI, you just do the first times the first, which is 25. And you do the last times the last, which is minus, and 2 root 3 times 2 root 3. Well, the root 3 times root 3 is 3, and the 2 times 2 is 4. 4 times 3 is 12. And this is going to simplify to 5 square root 3 plus 6 over 13. That can be rewritten as 5/13 square root 3 plus 6/13 if you want to, but it's perfectly fine to leave it in this form. Okay, page 4 brings us to the end of lesson 9. Review the lesson summary and go to your problem set.